We're going to go ahead and get started today. I think that I might have, I don't know what I was thinking when I kind of went through the pattern. Exam 2 is next week, and we're only doing 3 sections this week, and then we have a full week, and then next week is Exam 2 and the start of Unit 3. But that if you wait until the end of next week to take Exam 2, you're literally only going to have 2 weeks for all of Unit 3. So we're gonna talk about that again in a minute, but I almost crapped myself when I noticed that, because really you should be taking Exam 2 this week to give yourself more time for Unit 3, but it is what it is. So this week we're just doing 3 sections. It's a pretty easy week, which I guess isn't too bad since we had a holiday in there. Finishing Unit 2, the last 3 sections, 1 quiz, 1 discussion board, and that's it. So my recommendation to you would be to finish this stuff by, I don't know, Friday or Saturday, and prep for Exam 2, maybe Sunday, Monday. Take that exam either Monday or Tuesday, and that way then you have the rest of next week to get into Unit 3, because the more, or the quicker you can get into Unit 3, the easier it's going to be for you. All right, so next week, as I just mentioned, take the exam early in the week. If you wait until Saturday, unless you choose to start Unit 3 before you take the Unit 2 exam, which I think just sounds odd, you know, that'll be the best. Take the exam early, darn it, take the exam early in the week, Monday or Tuesday. Give yourself the rest of the week to really start getting into Unit 3. We also have a bit of an issue with next Wednesday's live session. I'm in Indianapolis Sunday through Wednesday for some training, and we get done on Wednesday at 3:30. So I potentially can meet at 4 o'clock on Wednesday, or we could do Thursday at 1 p.m. So, you know, there's 4 of you here right now, and you 4 come generally every week, I think. So I'm going to let you guys kind of decide. Does anybody have a preference? Wednesday at 4, Thursday at 1? Potentially we could do both. You know, I don't know if one works better than the other. Do any of you have an opinion? You can either speak or chat. Samantha says Wednesday at 4 is fine. Wednesday at 4. Okay, so since you guys all said either one, or we're going to go Wednesday at 4 p.m. for the next session next week. That will be a new link, so you will have to hit the link and register again like you did at the very, very beginning, because it's a different time. So I will get that link in an announcement after class today. So and I'll probably send out some reminders of that there will be no session at 1 o'clock because I'll still be in training, but I'll be done by 4 and can be on my computer at the hotel by then. So that should not be an issue. Okay, so Wednesday at 4 next week it is. That was fantastic. All right, do any of you have any questions over anything before we jump into this here 3 sections? Everything's going okay? All right. So we have 3 sections this week, 16, 17, and 18. 16 and 17 kind of go together, probability dealios. 17 is basically 16 on steroids, right? No new concepts. You just have to create the table. And then 18 is kind of its own breed. It's just its own thing, and not too bad. So what we're going to do first is kind of get into section 16, which is probability. And I think most people have heard of probability or dealt with probability in some aspect of their life at this point. So right, probability is just a chance that something can happen. When we write or find probability, you can write it as a fraction, a decimal, or a percent. The big thing to remember is that if you write something as a fraction, you do need to reduce it. So that's kind of the big key there. I prefer a decimal, my own personal preference. I don't care what you guys do. You do what you want to do. When I do probability, I almost always write it as a decimal unless it states otherwise. That's just my personal preference. Rules, there are 3 rules for probability. All probability has to be between 0 and 1. And if you think about this, it makes sense. A probability of 0 means that things can't happen. Like when you go outside, well, you're planning an outside event, so you look at the weather. A probability of 0% rain means it's not going to rain. It cannot happen, right? 0%. Whereas 1 is like 100%. That means it will happen. Like what is the probability you'll have math homework? Well, that's 1 or 100% because you definitely have math homework. Everything else is going to be between 0 and 1. So you might have a probability, like 0.45 or 0.7. Those are possible probabilities. You cannot have a probability of 1.2. That's greater than 100%. That doesn't work. So they have to be between 0 and 1 inclusive. Inclusive just means that 0 and 1 are also possibilities for probability. Rule number 2, the sum of all probabilities must be 1. If you think about this logically, that should make sense. If you're picking pencils out of a bag, if you want to find the probability of each color, right, probability of picking a red, probability of picking an orange, a yellow, or whatever, if you add all of those probabilities together, they will add up to 1, where 1 is 100%, because all of the probabilities is everything, the entire unit. And remember, we talk about all, well, all is 100%. So logically, hopefully that makes sense. And then the last one is just the way to find probability, which is the number of ways it can occur over the overall total possibilities. And of course, we will be doing a few examples. So that's just kind of the basic excitement there of probability. So let's get into some examples here. We'll start easy. We're going to roll, we're going to roll a 6-sided die. What is the probability of rolling a number greater than 1? All right, well, sometimes with probability, I like to think through it in words first. So when we're talking about probability, always starts as a fraction. The top is what you want to have happen, right? I want a number greater than 1. So a number greater than 1. And on the bottom, we want total possibilities. Okay, well, if you're rolling a 6-sided die, how many total possibilities do you have? That should be an easy one, right? 6-sided die, how many total possibilities of numbers do we have? 6. Thank you. Good work. So we have 6 possibilities. There's our denominator. Now, thinking about a 6-sided die, how many numbers on that die are greater than 1? 5. So the probability is 5/6. Or you could change that to a decimal, 0.833, which means 83.3% of numbers on that die are greater than 1, right? Any of these are viable options of how to write that answer. Just really depends on what the question is asking. Make sure you're paying attention to that. If it wants a decimal and you type a percent, right, you're wrong. So make sure you pay attention to the details. All right, the next 5 problems, we're going to use this same probability table. So we've got males and females. We've got 3 colors, red, blue, and purple. And a lot of the probability that we're going to do in this class will come from a probability table. So it's important that you kind of understand how these all work. So first we're going to start out easy, and we'll get increasingly more difficult and add some other pieces. But first we just want, what's the probability that somebody chosen at random likes red? Well, all we care about is red, right? So we're talking totals. We're talking red over the total. Notice how I used a red pen there? Yeah, did that on purpose. All right, so how many reds do we have? Total reds. We do not have 36. 18. There we go. So total red comes here. Out of the total, because we're just pulling from everybody, we have 80 total people. So our fraction would be 18 over 80. Of course, that would need to be reduced. Can anybody change that to a decimal for me, please? Let's go to 3 decimal places. 0.225. Thank you, Nathan. So 0.225. So basically, you have a 22.5% chance of picking somebody who likes red, right? Very straightforward. We just care about red out of the total, and that's it. You're going to stop me if you have any questions, all right? Otherwise, we're just going to keep motoring. All right, we've got the same table, and now we're looking, what is the probability that somebody is a female? So instead of looking at the red column like we did last time, now we're going to look at the female column. So now we're looking females over the total. What does that look like as a fraction? Give me a fraction first. Females over totals. 40 out of 80. Beautiful. And let's, oh, 1/2. Somebody even reduced. High five there. Good job, Nathan. And let's go ahead and go then to a decimal. 0.5. Very good. Right? Again, another straightforward, but it's important that we understand, you know, sometimes we're going to look horizontally, sometimes we're going to look vertically, depending on what the question is asking. All right, now we're going to get into a little bit more confusing stuff here. So, what is the probability you're going to choose a male who likes purple? So here's the key. We want a male who likes purple. That has to be true. Oftentimes, these will be combined by the word and. In this particular problem, they're not. But right, we want a male and we want that person to like purple. So male and purple over the total. So how many people in this particular table are males who like purple? 10, exactly. With and, we think of this as intersection. So intersection, think about like if you're driving the male train, you're driving the purple train, and at 10 is where they intersect. Out of the total, we still have 80 people total. What is 10 over 80 as a decimal, please? 0.125. You guys are rocking this probability stuff. All right, so 12.5% chance that you choose a male who likes purple. Very straightforward. Okay. So far, so good. I like it. Everybody's answering, so that helps. All right, so now we are going to the probability of a female or someone who likes red. Okay, so the key word here is or. Now, there's a couple different ways you can do this. I teach it one way because that's how I was taught and that's how my brain works. So if you can think of a different way, I'm not going to talk about it, but there are multiple ways to do this, okay? So we want a female or somebody who likes red. Now, if you think about this, female is all of these people, and red is all of these people, right? You'll notice how we talked about these people twice, right? The females who like red got counted twice, and that's an issue. So when you're thinking through this, if we take the females out of the total, right, this is all the females, plus all the reds, because that's what we want. We want females or reds out of the total, but we need to subtract the overlap. And the overlaps are the female reds, right? The spot that I highlighted. And this is how I do all of these problems. And the reason this is how I do them is because in real life, not every probability problem comes from a table. And in a table, things are very easy to, oh, wow, I'll just add up those few numbers and there's my answer. Yeah, but what if you don't have a table? You know, I don't know what you guys are all majoring in, but some of you potentially are going to have exams that you have to take in your field that will include math. And there may be probability without probability tables. So if you don't understand the concepts, it's not going to help you. So that's why I do things the way I do. So in thinking through this, if I take my total females, and we know our total females is 40, so I have 40 over 80. And then I've got red, well, I've got 18 total reds out of 80. And then the overlap is 6. So the reason, again, that we subtract that 6 is because we counted them twice. They were counted both as females and as reds. So if we subtract it, now we're only counting them once. So adding, subtracting fractions, we add and subtract across the numerators. 40 plus 18 is 58. 58 minus 6 gives me 52. And my denominator stays the same. So the probability of choosing a female or someone who likes red is 0.65. Questions on that particular problem? Everybody okay with that? Makes sense where all those numbers came from? Because that's the key. If you understand where things come from, it makes it a little easier to kind of play with it. Okay. If there are no questions, then we'll move on to the next one. There's one more type of probability that we're going to deal with, and that is using the word given. So use the table below. What's the probability of choosing someone who likes blue given it's a female? The word if sometimes also, if it's a female, kind of the same thing. What that implies is we only care about the females. When you say given it's a female. So we've narrowed it down. We only have females in the room. We want to know blue. So we're talking blue over females. Notice how the given or the if, these are called conditional probabilities. And conditional probabilities, they simplify what you're dealing with. You're not dealing with the total anymore. Whatever follows the word given that it's a female, whatever follows given, that's going to be your new denominator. So given a female, we're now looking at a females. What would be my fraction here for blue out of female? Good, 26 out of 40. Oh, and reduced. Excellent. 13 out of 20. And as a decimal, same as last one, 0.65. So really with probability, the key is identifying a few words, right? In this one, we had to identify the word given. Given tells us it's a conditional probability. We're narrowing down our field. Or tells us we need to add and then subtract the overlap. If you see and, then you're looking for the intersection. Those are all key words here in probability. Right, and that's section 16 in a nutshell. We did basically one of every type of probability. If we have time at the end and you want to do more of anything, you let me know. We can, I can come up with a new table in a matter of 13 seconds and we can throw problems at it. So, but that's kind of your basic introduction to 16. And now we're going to get into section 17. Section 17 is one of my favorites because I think it's the most interesting, or one of the most interesting sections. And it deals with false positive, false negatives, which are an application of probability. So false positive, false negatives, I think are most easily associated with medical field. So a false positive is when you test positive, but it's wrong. So you go into the doctor and they say, hey, guess what? You're pregnant, right? Because the test showed that you're pregnant. So it was a positive pregnancy test, but you're really not. So it's the positive part tells you that's how you tested. So when we're talking about a false positive, this positive is how you tested. The false is because it was wrong. So you tested positive, but it was wrong. Same goes true for a false negative. If you test negative, so you go and you think you're sick, you don't feel good, you have a sore throat, you go in, they do a strep test, and it comes back negative. So the doctor says, nope, you don't have strep throat, I think you're just a weenie, go home. So you're told that you're fine, you don't have strep throat, but it's false, you're totally infected, you actually do have strep throat. So false positive, false negative tells you how you tested, but the test was wrong, right? Which totally happens in all sorts of different areas. There's no right or wrong answer of which one is better, which one is worse. If you go through section 17, the different examples there, some of the questions is which one of these is worse. Well, that totally depends on the way you're looking at it of a false positive, false negative, because you're going to have different reactions to both things, right? If you have strep throat and and your test negative, so you don't think you have it, you may go kissing on people and infecting all kinds of people, right? That could be totally bad. Yeah, so there's pros and cons, right, to both of them, I guess. All right, so let's get into this. Now, the reason that this is different than section 16 is that you have to create the table. So you're going to be given a story problem, right? Lots of words with a couple of numbers, and then you're going to have to come up with the table. For all of your web work problems, you don't even have a blank table to start with. You just have the word problem. So the more you do of these, the easier they get, I promise you. So I always start with these. This is kind of my basic outline. I always have, let me see here, give me a pen. Positive test here, negative test, and then you have it or you don't. It doesn't matter what the problem is, whether it's a disease or an allergy or a savings account. You either have it or you don't. Those are your two different things, right? So you can kind of use the same basic table for every one of these problems. So, all right, we're going to go ahead and we're going to walk through this together. I only have one of these in this section, but if you guys want another one to like try on your own, I can come up with one pretty easily. So let me know. Okay, so first of all, 3% of people are allergic to snakes. I made this up. A test with 92% accuracy can be used to test for this allergy. Use a sample of 50,000 to create a table to answer questions A through D. Now, before we really get started with the numbers in this, I want to let you know that that 50,000 could be anything. We could use 100,000, 200,000, 500,000. We could use 10,000. And your probabilities would all be the same because you're doing proportional reasoning here with the percentages. So that 50,000 is kind of just an arbitrary number, but it is what it is. So first of all, there's kind of a method to this madness, and if you kind of get behind the pattern and the flow, it works a little easier. So you always, 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 always need to start with this column. The overall total column, if you can't fill out this entire column first, it's not going to matter. So what do we know that would fit somewhere in that column? That column has 3 blanks. Do we know anything? Jessica, don't put a question mark. Be confident with your answer. We are going to start with the 50,000. Okay, so I want to address the 92%. Let me get a different color. I wish I had more than one highlighter in this thing. Accuracy rate is always going to fall inside here because the accuracy rate deals with the whole testing piece, right? You're testing with 92% accuracy. So positive test, negative test, the accuracy, the percent, that number is going to be used to fill in these 4 boxes. Okay, so we are going to start with the 50,000 as Jessica mentioned, and that's a total, right? We're starting with 50,000 people. Okay, so we've got 50,000 people. Now, they tell us out of those 50,000, 3% are going to be allergic to snakes. So that's has allergy. 3% of 50,000. When I say the word of, what does that mean in math? Of means what? Multiply. Very good. So when I say 3%, I'm going to change that percent to a decimal. 3% of 50,000. This is how many people have the allergy. What is 3% of 50,000? 1,500. Excellent. So out of those 50,000, 1,500 of them are going to be allergic to snakes. All right. Now, using your, I don't know, thought process, how can we find that missing number? If 1,500 have the allergy, how do we find how many do not have the allergy? There's actually a couple different ways to do it. Can anybody think about it? You've got 50,000 people total. Very good, Nathan. Yep. So we're going to take the total of 50,000 and subtract those 1,500 with the allergy because everybody else doesn't have the allergy, right? So that's 48,500. So those blue numbers have to be your first step. Have to be. All right. And sometimes they will give you percent, like in this problem. Sometimes they'll just say start with 50,000 and 2,000 have the allergy. They might give you the number, but at any rate, you have to start with that column. Okay, now we're going to go inside, and I'm going to start first with just those that have the allergy. Okay, as mentioned earlier, the 92% accuracy rate is what we play with inside here. Now, think through this logically. You have the allergy. You are allergic to snakes. If you go into the doctor and they test for that, do you expect to test positive or negative? If you have the allergy, you would expect to test what? Positive. Exactly. That's with anything, right? If you think you're pregnant and you go to the doctor, you expect to test positive. That's kind of how this works. So the 92% is going to be used here. 92% of all people who are allergic are going to test positive. So 92% of the 1,500. So 0.92 times 1,500, because you expect to test positive. That's where that accuracy rate. If it's accurate, that's where it's supposed to happen. Okay, so what is 0.92 times 1,500? 1,380. Okay. All right, now again, think about looking across at the allergy people. We had 1,500 allergies total. 1,380 of them tested positive. How do we figure out how many tested negative? Exactly. So we take the 1,500 total that we had, we subtract the 1,380 who tested positive, and the rest of those poor fools tested negative. So they think they're fine, they end up getting bitten by a snake, and they probably died. Okay. Now, let's continue on. Now we're talking about those that do not have the allergy. Okay, so you are not allergic to snakes. If you go into the doctor, do you expect to test positive or negative? If you're not allergic. Negative. Exactly. So this is where the accuracy rate will come in for this one. 92% times the 48,500 people who are not allergic. So how many people will that be? 44. Ooh, I don't have 160. Did I multiply wrong? Totally possible. No, I think you multiplied wrong. Yeah, 620 is what I got also. 44, 620. Which happens, right? Numbers happen. Okay, so we had 48,500 total. 44,620 of them tested negative. So same concept here. We take 48.5, right? Total non-allergies. Subtract the ones who tested negative. That's a 620. And how many positive testers do we have? $3,880. Very good. All right, so hopefully you can see the math here isn't hard. We're multiplying and we're subtracting. Those are the two, yeah, multiplying and subtracting. Those are the two things. But you've got to understand where the numbers come from. And that's kind of where it gets tricky. So the more you do these, the easier it gets because those things are just going to make sense. All right, so then the last step to create our table, we haven't even answered a question yet. The table, we just need to add up our positive tests. So what's the total number of positive tests and the total number of negative tests? Samantha, those are the people who have the allergies. You gave total allergies. We want these two. So 5,260 people tested positive. Not all of them have it, right? 3,880 of them don't have the allergy, but they still tested positive. And then the negative test, as Jessica mentioned, 44,740. these two blue numbers should add up to 50,000. So that's something that you should always double check, that your positive and negative tests together add up to your total number of people. Okay. Does that make sense how we came up with that table? Okay, the next question, do you guys have this table written down? Because I need to erase it to move on to the next page, but we need to reference it. So if you guys have it written down, then you'll at least know where the numbers are coming from. Does everybody have it written down? Yes, no? Yes, yes. Good. I mean, I assume that you guys play along. You come up with a number, so I figure you probably write them down. Okay, so I'm going to erase this. We're going to move on. We're going to answer 4 questions that go with this exact table. So actually, let me see if I can just, yeah, this will work. Okay, so 7A, how many false positives are there and how many false negatives? So this makes you kind of think through where are those things located? Okay, so let's talk about a false positive. If you're a false positive, how did you test? A false positive will test positive. Okay, so false positive tested positive, so we're looking at this column, but it's false. So which one of these numbers, 1380, 3880, or 5260, which one of those shows a positive test that is wrong? $38.80, exactly. False positives, $38.80. Because they tested positive, and if you test positive, you should have the allergy. But those 3880, remember, are those who do not have the allergy, so it's wrong. So those are the false positives. All right, same concept now with false negative. If you're false negative, you tested negative, but it's wrong. So which one of these 3 numbers shows a negative test with an incorrect result? Nope, Jessica, that is incorrect. 120. So remember, if you test negative, you expect to not have it. But 120 people actually do have the allergy. Remember, the top has the allergy. So if you test negative, you should not have the allergy, and 120 people do have the allergy. Okay, that makes sense so far? Okay, good, good, good. All right, so let's go to the next question. 7C. It's kind of, we're getting a lot of messy here. That's all right. So, given a positive test result, what is the probability that someone does not have the allergy? Thinking through in words. Okay, we want to know they do not have the allergy. So not allergy is what we're looking for. Are we looking out of the total, or who are we looking at? No, that number there has nothing to do with this one. What's the key word that we're showing here? From section 16, we have the word given. Given a positive test result. That means we only care about the positive test results. Do you remember that? So when you're looking at this, positive test result is this spot here circled in our new blue. So the total positive testers is our denominator. That will be 5260. And not allergy. Which one, the black number or the green number, which one of those represents not allergy? The green number, exactly. So we end up with 3880, which is a probability of 0.738. So 73.8% of positive testers are not allergic to snakes. So if you go, this made up example, you go in, you get tested and they say, yep, you're allergic to snakes. With this kind of probability, I'd be like, I would like to be tested again because there's a 73.8% chance you're wrong, right? This is our false positive probability. Tested positive, but it's wrong. All right, we've got one more to go with this problem, which is lucky because this is a hot mess over here. All right, so now we say given a negative result, need a color I haven't used yet, probably somebody does have the allergy. So same, oh balls, there we go. Same thing, we have the word given. Given a negative test result. So now we're looking at negative. Guys, I got to clear this screen. I need some space. There we go. That was rough. Given a negative test result. So now we want negative on the bottom. What is probably, so write the negative results. What is probably somebody does have the allergy? So does have the allergy. So you're looking at just the negative column. What's the total of all the negative column, not negative testers? Oh, heck yeah. There's, we got total fraction there. You've got 44,740 negative testers, and out of them, 120 of them have the allergy. So you end up with 0.003. This is our false negative probability. So if you go in and they say, nope, you are not allergic to snakes, go on your merry way, there's only a 0.3% chance that you actually are allergic. So that's generally lower. It seems to be that the false positive value is usually higher than the false negative, simply because more people don't have diseases than do, for the most part. And that's what causes that probability. Okay, so that's false positive, false negatives. How do you feel about that? Questions, comments, concerns, suggestions? Again, the more you do these, the easier they get in terms of creating the table and then playing with them. In the back of your packet, I think there are 5 additional false positive, false negative questions, and there are videos that go with them. If you want that practice and you can't find those videos, shoot me an email. I can get them to you pretty quickly, because it really is, you know, you do a few of these and you'll feel better about them. All right. If there are no questions on false positive, false negatives, we're going to just continue motoring right along. And we're going to head into section 18, which is margin of error. Okay, so I said earlier, 16 and 17 kind of go together. I hope you guys saw that. Where 16, you were given a probability table, and then you answered a bunch of questions about it. In 17, we created the probability table, and then we answered questions about it. So those two are very related. And now we get to section 18, which is kind of out in left field compared to where we just were. Totally different train of thought. You're going to want to kind of get yourself out of the probability world and just into, you know, polling, if you will. So if you paid attention during, I don't know, any election time, presidential, Senate races, local, anything, they oftentimes will talk about things with margin of error. So they might say, you know, Bill Nye the Science Guy is leading the Green Martian by plus or minus 3%, right? And this plus or minus 3% is the margin of error, right? They might be off. And the reason they're off is because when they poll these kind of things, there's no way to talk to everybody. It's impossible. So they use a sample. And when you use a sample, and we're going to define all of these words officially, but when you use a sample, you have a chance to be wrong, right? I could talk to 20 people, and all 20 of them could say that math is their favorite subject. That doesn't mean that the entire country feels that math is their favorite subject. So your sample could be wrong, which is why we have this margin of error. So the key things to remember here when we're going through these definitions is that when we talk about a population, we're talking about all possible subjects. And when I say subjects, I mean people, I'll just say people that we could talk to. So if you're going to do a survey of U.S. adults, the population would be all U.S. adults, because that's everybody that I could pull from. Well, as I just mentioned earlier, there's no way that you could talk to everybody. There's just not enough time or money in the world to talk to everybody. So the sample is the number of people you did talk to. So when you're defining the population is everybody, and the sample would be 45 adults in the U.S. because I only talked to 45 people. Okay, so the population uses the word all. Sample will use an actual concrete number. Okay, so the margin of error, get a new color here. Basically, the margin of error is the variation in responses, meaning if I talk to 45 people today and ask them what's your favorite subject, I will get, some answers. If I go out tomorrow and ask 45 other people, I may get a different answer, right? A different probability or different proportion of people saying things. So the margin of error is the variation in responses, right? That plus or minus 3% type of a dealio. All right. The 95% confidence, we're going to write confidence intervals. So these two pieces kind of go together. In this course, we are always going to be 95% confident. If you would take a statistics course, because this kind of borders on introductory statistics, with stats, you can find a confidence of any level. 80% confidence, 90, 99, 97, 96, it doesn't matter. You can find any of them. In this course, we do an estimate, and we find the 95% confidence by taking 1 over the square root of n. And I failed you a little bit because n is actually your sample size. So if I talk to 45 people, well, just in this particular problem here, I would take 1 over the square root of 45, and my margin of, this is I'm falling apart. This is our margin of error that we use to be 95% confident for the confidence interval. These three pieces all go together. Okay, but the 1 over the square root of n is the margin of error estimate for 95% confident. So, I'm sure I thoroughly confused you by now. We would have, I'm just going to go to 2 decimal places, 0.15. So that's 15%. So I would say that my answer, whatever it's going to be, could be plus or minus 15%. That's a very big margin of error. So I can be 95% confident that I'm going to be within a certain value. I don't have any values to start. So the confidence interval will be 2 numbers. Okay. This is basically the 5 questions that you're going to answer. You're going to write in a sentence. I'm not making any damn sense at this point. Okay, so this is what we're going to go through. It helps when you actually have a problem that you're dealing with. So let's jump into a problem so I can stop blabbering and we can do something. All right. A recent survey of 2,400 U.S. adults found that 36% of adults think that the Cubs are overrated. I am not a Cubs fan, and therefore I approve this message. So we're going to go through and we're going to answer 5 questions dealing with this problem. So first things first, A and B kind of go together. What is the population here? Who are we surveying? The key word there, Nathan had it, is all. So the population is all who? We didn't talk to all people, we just talked to all U.S. adults. So the population is all U.S. adults. If I want to do a survey, if people think the Cubs are overrated, the possibilities that I can choose from all the adults in the U.S. So think, if you're thinking probability, population is that denominator, right? Everybody. The sample is what goes on top. That's who you actually talk to. So now, Samantha and Jessica, I think you guys both answered the sample question. Our sample is how many people we actually talk to, right? So that's where the 2,400 comes in. 2,400 U.S. adults. Okay? Because the sample is who you actually talk to. The population is your possibility of talkers. Right? There's the difference between population and sample. Okay. Now we're going to estimate the margin of error for this particular sample size. And again, because we are dealing with 95% confident, our margin of error will be the 95% confidence. So we're going to use the formula 1 over the square root of n. What is my value of n in this particular problem? Good, it's our sample size. So 1 over the square root of 2400. All right, so let's go ahead and change that. Let's go to a percent, nearest percent. Depending on your calculator, sometimes typing in 1 over the square root of 2400 can be tricky. You might have to type in the square root of 2400 first and I got approximately 48.99. And then work it out. Then you should get 0.02, which is 2%. So our 95% confidence margin of error is 2%. If you have no idea how to do this on your calculator, the easiest way for me to help you is for you to take a picture of your calculator and email it to me. I've dealt with a lot of different calculators, and I can usually tell by looking what buttons you're going to have to push in order to get it there. So if you can't figure this out, how to find the margin of error on your calculator, send me a picture and I will help you. Okay? Okay. Anybody have issues with letter C? Did everybody get the 2%? You're okay with that? Okay. So now we're going to the confidence interval. And this is where the 36% comes into play. When they give you the data in the problem, 36% think the Cubs are overrated. This 36% is what we call the point estimate, right? Because they only surveyed 2,400 adults. And we all know there are more than 2,400 adults in the U.S. So this is an estimate of what we think. So for the confidence interval, we're going to take that point estimate, the 36%, and then we're going to add and subtract the 2%, right? Plus or minus 2% in order to get our interval. So to get the low end of the interval, we're going to subtract. We'll take the 36 minus 2. To get the upper end, we're going to add. We're going to take 36 plus 2. So our confidence interval, 36 minus 2 gives me 34%. And adding 2 gives me 38%. So my 95% confidence interval is 34 to 38%. Okay. You're going to stop me if you have questions. And the last part, you're going to write a statement using your answer to part D. Now, there are 4 pieces that I'm looking for when you're writing a statement about this. Okay, and I'm going to hopefully write this in a way that you can actually read it. So you're always going to start with, we are 95% confident. You always got to start with how confident you are. Right? Because remember, in a stats class, you can have any level of confidence you want. Well, here, it's always 95, but you still need to state that. So we are 95% confident that between, and now we use our, so that's between 34% and 38%, right? There's our interval. We're 95% confident that between 34 and 38% of U.S. adults, because that's who we talk to, and then what are they doing? They think the Cubs are overrated. Boom. So I said 4 pieces. Let me just kind of 95% confident, confidence interval, population, and what are they doing? Those are the 4 pieces to your sentence. Okay, so it kind of works that, you kind of work through it in the, A through D. And that, my friends, is the end of today's lesson. 16, 17, 18, probability, false positive, false negatives, and margin of error. Who has questions for me? None? All right, then, as I said at the beginning, highly recommend you do as much. Okay, Jessica, let me finish my thought, and then we'll bring up whatever you need. Highly recommend you finish Unit 2 by Friday or Saturday at the latest, and then you study for Exam 2, maybe Sunday, Monday. Have that exam taken by Tuesday. You do need to make an appointment. So if you haven't made an appointment with the testing center, you're going to want to get that taken care of. But get that test taken earlier in the week. That way you can jump into Unit 3, hardcore. You don't want to wait until Saturday night to start Unit 3, because then you're down to 2 weeks exactly to do 9 sections in Unit 3. And actually, I think there are 10 sections in Unit 3. And there's just a lot of work. Unit 3 is the most, it's the most interesting, but I think it's also maybe the most work. So, you want to make sure that you get started as soon as possible. It'll make your life easier. So I think it'll be the easiest for you guys because you're adults, and the first 4 sections are financial, and most people have dealt with financial, so it makes sense to them. So okay, if you guys don't have any other questions, if you don't have questions, go ahead and take off. Jessica, let me clear this screen, get ourselves a clean slate here, and then you can ask away and we'll go with it. Okay, so thanks to you guys who are leaving, and if you want to stick around and have other questions, let me know. If you have any other questions about Exam 2 or anything else, shoot me an email, and I got you guys. Okay, Sam's got questions too. All right, what do you guys got?
Hey, Becky. It's Jessica. I have a couple questions over section 11, 13, and 14.
Okay.
So unless if Samantha has less than me, then she can go ahead and she can go before me. It doesn't matter.
Samantha, okay, so you said 11, 13, and 14. And Sam said 14 as well. Okay, well, then let's start with 14. Do you have a particular homework question that you're looking at?
Oh, boy. Yeah, okay, it was on the question. Well, for me, I had 5, 7, 9, 10, and 11, and they were all set up the same way. For the third part of that question, I couldn't get it right, but the other 2 parts of the question, I was correct. I don't know if Sam had the same issues as me or not.
Okay, so let me get into web work. All right, and you're okay if I bring yours up so people can see your web work?
Yeah, okay. I don't care.
All right. I always need to ask that since this is being recorded. Okay, so here's my whole class list, okay, so section 14. Let's start with problem 5 just to look at it. All right, so you got these 2.
Oh, except for that first, problem 5. That was the one that wasn't the same as the other ones, but I still have an issue with it.
Okay, so taller than, okay, so did you, for these, did you draw yourself, look how straight that line is. That is ridiculous. Did you draw yourself the curve with all the numbers in it?
Yes.
Okay.
Yes, I did.
Perfect. That is crucial. So you've got 69, and we're 2.5 inches. So this is what, 71.5, and then we get to 74. So this question, taller than 74. So we're looking for this probability over here, right? Because taller is to the right. So if you recall, we've got 34. This is 13.5. There's one more line in here. So this is 2.35 and 0.15. Okay, and it's asking for a percent, and these are percentages. So if we're looking to the right, you're looking for basically these two percentages together. And that should be the right answer.
Okay. So I just added those two up and subtracted from 100, right?
No, you don't have to subtract from 100 because you're just adding them together.
Oh, okay.
That's what you want. You want those two numbers.
Oh, okay.
Yeah, and make sure that you put the word percent at the end because that question says you want percent at the end, just like you did with inches.
Gotcha. And in part B, I think it said I was incorrect on that one as well. I'm not sure why I am.
So
but
if we go back, let me just finish typing. So 34, 13.5, 2.35, and 0.15. Okay, so they said about 2.5% of men are shorter than blank. Okay, so 2.5%, I need a new color. Well, these two together are 2.5%. So this line here, whatever this value is, 2.5% are going to be shorter than him. Does that make sense? So like you have 69 in here now. 69 is the mean. So right now, 50% of people are shorter than 69 inches. If you just want 2.5%, that's represented by these two values. So you want the value for this bar. So whatever that bar is, that's going to be your answer there.
Okay. And to do that, I just do the same thing like you just told me before. I just add the 2.35 plus the 0.15.
0.15, right. Well, that gave you the 2.5%. So they, in part B, they say 2.5%.
Oh.
So you're kind of working backwards. In part B, you want the value, and in part C, you want the percent.
Gotcha.
So they're asking, they're kind of opposite questions. Yeah. Okay. All right. Back to the problem. Erase that. All right, so we'll go to number 7. And a YouTube video on what? On section...
Yeah,
Sam, just... do you have...
Sorry.
Standard deviation in general. There are... well, like for this particular problem, in problem 7, you can see this hint down here. There's a video example. So there are YouTube videos that go with particular problems. I know that there is a video of the empirical rule in general, right, which is the 34, 13, 2.5%. In terms of standard deviation in general with z-scores, I don't know. I mean, I can make it.
Well, I guess I have in Excel. Is there a possible way to plug in those numbers and have it sorted out from least to greatest, or we have to do that on our own sheet of paper and then plug it into Excel?
At least, no, you can do that in Excel. I can show you.
Yeah.
Yeah.
You?
Yeah.
If that's all right with Sam.
Yes. So, so I'm trying to answer Samantha's question in the chat box here while I'm thinking of this. So Samantha, if you are having trouble in section 14, right? So more than likely the empirical rule is the issue, whereas, but if you have particular questions that are troubling you, I mean, I can look at them and send you an email of kind of a overarching where the issue is. And if you need a video, I can make you one when I get home. I don't have my video stuff with me today in the office, but we can do that. So if you want to type in what you want from me, I'll make it happen. Okay, so in Excel, how to sort things least to greatest. So first, I'm just going to give us a bunch of numbers. Okay, so you've got a bunch of numbers and you want to sort them. So if you look up here, you should see a button that says sort and filter. If you only have one column, it's not too bad. I don't know if you have to highlight it or not, but sort smallest or largest, you just click on that and it will renumber them. It gets to be a little more tricky when you have multiple columns that correlate together, but if it's just one column, there it is. So then you know that your minimum is up here, you know your maximum is down here, and then you can find your range by taking your max minus your min, and there's your range. Yeah, but with these problems, when it says, you know, you want to use these pieces, you need to use Excel, because if you do it by hand, you might be off by a little bit, and that's going to jack up all your answers. So you want to make sure that you're using the formulas in Excel, the standard deviation, the average, the median. Yeah, just like we did in section 8, basically.
Right. Okay.
Yeah.
Yeah, because I think what happened on that problem on my web work, I think, what was that, problem 5 or 6? Sorry, which one was that? I can't remember.
Okay, so section, wait, I gotta find the right
7. I think we're on problem 7.
So we're on problem 7 is what
7.
we have up. Okay, so thinking generally, if you look at the numbers that are given here, right, they're all in the 200s, right? So your mean and your median and your mode are all going to be somewhere in the 200s. They have to be, because they all represent your data. So the fact that you got a mean and a median that are greater than 200, that shows you right there that you have an issue.
Okay.
Right.
Yep. I think I just plugged it. Well, what I did was I wrote all those numbers down on my paper, and then I sorted them out least to greatest. And probably somewhere along the way I screwed up, and when I plugged them in Excel wrong.
Oh yeah. And it only takes one number off to just jack everything up. Yeah.
Right. Okay.
Yeah. Okay.
These were the questions with the part 3 I was having issues with.
Okay, so all right, so well, the good part is you got the top 2 right. That's the hard part, really, because the bottom, you're going to go back to what we did at the very, very beginning. So that's where you've got this, and now you know, right, part A, you got the mean. So you have 98.9, oh, that's not good, 98.9, and your standard deviation is 0.6. So if you add 0.6, you're at 99.5, subtract it, you're at 98.3, blah, blah, blah. And, oh, wrong button. You've still got the 34, you got all the percentages, right? So this problem down here says, what's probability of a body temperature more than 98.3? Well, 98.3 is represented by this line. So if you want more than that, you're just going to add up all the percentages to the right, because more means to the right. So 34 plus 34 plus 13.5 plus 2.35 plus 0.15.
84. Yeah, and I put that in before, and it said it was incorrect. I think I did. I don't know if you can see my previous answers, but I'm pretty sure I put in 84.
I gotta get out of a different tool here. Why can I not? There we go. Show past answers. Of course I can see your past answers.
Okay.
Wait, let me. You typed in 84, but not 0.84, right?
Oh.
84 is a percent, but you don't want it as a percent. You want it as the probability, and it says round to 4 decimal places. So if you would type in 0.84, then you'll be correct.
Okay.
Yeah.
Gotcha. And that's probably my issues with 10 and 11 as well.
I would say probably, yeah. If you got the first 2 parts right, yep, I would say that's probably your issue. Yeah. Okay. Yeah, but it's all based off, draw yourself the picture of the normal curve with the percentages and the numbers, and yep,
okay.
They're all, yep, they're all the same. Yep.
Okay. Alrighty, that makes sense then for that section. And this is a big jump back. Section 11.
Well, hold on. Let's see if Samantha has questions on 14. Let's do her 14s before we jump back. Is that okay?
Yeah, I'm sorry.
No, you're good. You're good. No problem, no problem. Samantha, do you want to talk about anything from 14? Or do you want to just watch that video and see if that works? Okay, you're good? All right. Okay, then Jessica, back to which section?
Okay, all the way back to section 11.
11. Okay. Would you say number 3?
Yes, ma'am.
All right.
You got it.
Wow, there's not a video for this one? I need to make a video. Let me write myself a note. This is
that's fine.
I've got my list of videos I need to make for the fall semester. Section 11, number 3. Okay.
Speaking of which, for the fall semester, do we have to, if we're signing up for classes for the fall, we would want to get in to do that now when we are, there's
Yes.
still time.
I would do that as soon as possible, yeah. Because I mean, I don't know, what's your major?
Nursing.
Yeah, those classes are probably going to start filling up because people like that stuff. So, you know, if you needed a math class, you could wait, but you don't need a math class because that's taken care of now. So yeah, I would make an appointment with your advisor as soon as possible to get in and get that taken care of.
Okay.
Yeah, yeah.
All right.
Okay, so this problem. So John's room is shaped like a box. It has a flat ceiling and a rectangle. Okay. Okay. Trying to think how to explain this.
Well, I think I have an idea. I need to find the area of the rectangle, and then the area of the windows and the doors, and then I would take those areas and I would subtract it from the whole area of the rectangle that he wants to paint, right?
Yes. Okay, so I think you have the right idea. And it's all really on how you look at it. So right there are 4 walls and there's 1 ceiling that he's painting. So basically you have 5 total rectangles that need to be painted.
Mm-hmm.
Right? So,
right.
You know, depending on how you look at this, 11 feet long, 8 feet wide, and it's 7 feet high. So you've got 2 walls that are 11 by 7. You've got 2 walls that are 8 by 7. And then you have a ceiling that's 11 by 8. Right? This is the ceiling.
Mm-hmm.
So there are 2 of these, and there are 2 of these. Okay, so what you can start with is saying, okay, pretend that these are all solid. What is the total area that he would paint if they were all solid? Okay, so that's kind of start with that thought process. If they're solid. But then you have a door that you're going to subtract. So you're going to subtract the door. And you have 2 windows. So you're going to subtract the 2 windows. That will give you the total area that needs to be painted.
Okay.
Does that make sense?
Yeah. So I would take 11. I would take the 11 by 7, multiply those, in which 77, and then the 8 by 7, or what I guess the easier way of doing it is, should I do 11 squared times 7 squared for the 2 walls? You
since there's 2 of them, you'll take 11 times 7 to get the area of that wall, and then multiply it by 2, because there's 2.
Okay.
And then so here you would take 7 times 8 for that wall, and then there's 2 of them, so you'd multiply by 2. And then for the ceiling, you would just take your 11 times 8. And there's only 1 of them, so you don't have to multiply by 2.
Okay.
Add those 3 together, and that will give you the solid, if they were all solid.
Gotcha.
Yep.
Okay, see, I think I was setting it up 11 squared times 7 squared, and then...
That would jack that up. The only, so then you also have to make sure that you change your inches to feet when you do your windows.
Okay.
Because everything is in square feet.
Mm-hmm.
Okay, so then once you get your area, your total area down here, right, that's not the answer to the question. So the question says he can paint 100 square feet with a quart of paint, and it costs $4.50. So you would take the total area and divide it by 100, right, for the 100 square feet, and that will tell you how many quarts and you're going to need, and you have to round up, right? Because 3.2 quarts, if you round down, you don't have enough paint. So you're going to have to round up to the nearest quart. And then you multiply that by 450 because it's going to cost you $4.50 per quart.
Okay.
So that's kind of the basics. If you can't get it, if you're working on it today and you really can't get it, I can make the video probably tonight if I feel like I've done this video. I might look to see if I have one already made somewhere.
Okay.
But let me know if you still aren't getting it, and I can make a video and send it to you so that you definitely have it.
Okay. Alrighty. Yeah. Thank you, Becky.
But
That
that's
was
kind of
wonderful.
the basic outline of that one.
I think I figured out where I was screwing up. No, of course, it was at the beginning.
Right. And it only takes one spot, and then you're toast.
Yes.
Yep.
That is for sure. Okay, and then let's see, where did I, also, in number 24 in section 11 as well, I guess, I had an issue with.
All right, certain drug dosage calls for 20 milligrams per kilogram per day divided into 2 doses. Person weighs 215 pounds. How much should be administered each time? Okay, so what did you do?
Oh boy, let me go back. Where did I do it? No, that was kilowatts. Did I write it down? I'm so unorganized in this notebook.
Okay, so notice how the drug dosage is milligrams per kilogram, but the weight is in pounds, right?
Mm-hmm.
So you're starting with your pounds.
Okay.
And the first thing you have to do is get rid of those pounds. So how do you get rid of pounds?
Convert it over to, I can convert it over to ounces.
Right.
But it wants kilograms.
Kilograms.
Right.
So you
I can just convert it over, yeah, 0.4536.
There you go. So 0.4536 kilograms is 1 pound. All right, so that right there will get you out of pounds into kilograms. And then you can use the what they give you, because they tell you there are 20 milligrams per kilogram. So that step makes your kilograms disappear. This right here gives you total milligrams. But you don't want total milligrams. You want divided into 2 doses. So what are you going to do to that total milligrams? If you want 2 doses out of it.
Divided by 2.
Divided by 2. Exactly.
Okay. Yeah, I don't know how and of course I'm going in for nursing, and that's a little sad that I couldn't figure that out.
Sometimes you just overthink.
I know I do. As you can probably tell, I do that quite a bit.
Yep.
I overstress and I overthink. Yeah, and I got a total of 97.24. Or 975.24, I'm sorry.
Sounds about right. Yep. Yep.
Okay, and then section 13, I only have one question. That was number 6.
Homework sets 13, number 6. I need to make a video for this one too. Okay. So actually it'll work pretty well using color here. So
yeah, because I tried going into Excel and figuring out.
Yeah.
And I'm still rusty with that. And then I tried looking back at over your videos for it, but that technique you showed where you cross it out and like the boxes.
That's what I'm going to
keep going until you hit the middle.
Yep, that's what I'm going to do right now. So you know you want to get into the middle, and you've got 64 families, so you're looking at like 32-ish, but you're even. So if you think about it, this first box here has 8 people in it, right? So I'm going to kind of go 8 at a time. So this is 8. This is 1, 2, 3, 4, 5, 6, 7, 8. So I just crossed out my 8 lowest over here and my 8 highest. Does that make sense to you?
Sort of, but those other boxes look smaller, so those just count as like a half, or would that just be a
Well,
whole?
see how this first line is a 2? So halfway through it. So these each represent 1, and these each represent 2. This one represents 4, so half of it, so this is a 2. So 2, 2, 2, 1, 1.
Gotcha. Okay, yeah, no, I see it now.
Okay. So let me change colors. So when we're looking at, I have 2 more right here, because this height is 2, so I can cross off these 2 down here. And this is just kind of the process. You kind of want to just, so this next box, the 4 to 5 box, is 6. So from 2 to 8, that's 6. So these cross out. And this is the way to find the median, is just to kind of work. And it is a little difficult when you're looking at a screen. And they don't have, if they had nice horizontal lines in it, that'd be easier. But from 8 to 12, actually this is 8 to 11. So this represents 3 right here, because this is about 11. So these 3 go with these 3. You know, and this is not the most exact way, but it's not bad. So now I'm going from 3, this is also 11, so this is 8 here. And if I get rid of these 8, now you'll notice the only bar I have left is 2. Right? Because this is 0 to 1, 1 to 2, 2 to 3.
Oh, yep.
So the middle, I mean, it's going to be somewhere in here, but it's still 2.
Okay. So in other words, the median would just be, would I go with the numbers along the left-hand side then?
These numbers.
Oh, I go with the numbers on the bottom. Okay.
These numbers these give you the frequency. These tell you how many are going to be there. So these you want to ignore when you're trying to find the median. You're just working on the middle.
Okay.
Yeah. Yeah.
Okay, yeah, that makes sense now.
Yeah. And, you know, you could always, worst case scenario, write them out, right? There are 8 of this first number, and that's a 0. So you could write out 8 zeros. The only problem is there's 64 numbers. And if you write them all out and then work your way to the middle, that just takes a lot of time.
Right.
Yeah.
And our quizzes and tests are time.
Right. Right. All right.
Okay, and I think, was that all I had? I think so.
All right.
I think that's it.
If there's any other ones, you know, feel free to email me. And if you still can't get a couple of these, let me know, because I do have some on my list of videos to make. So if I need to, I can make those videos sooner rather than later to get those to you.
Okay.
Just let me know.
All right, Becky. Yep, will do. Thanks a bunch.
Yep, no problem. Have a good one.
Hey, you too. Take care.
Bye.
Bye.